AMD's new AM5 platform has been on the market for a couple of months, so we still have a variety of feature-rich motherboards to look at. In this review, we have no less than 5 of ASUS's X670E product offerings, ranging from the high-end ROG lineup, the tough gaming option, and a mainstream Prime product. Let's take a closer look at the variety of motherboards that we have on hand here today. As a note, we've already covered the Ryzen 7000 series processors and the AM5 platform quite extensively in our previous videos and content, so make sure you check out the Kickguru YouTube channel and the kickguru.net main website for more information on those points. But let's get into this one. There's plenty to look at and to go through, so let's look at these ASUS X670E boards. Let's start off by looking at the two ASUS motherboards that occupy a very similar price point in the UK market, so around about £350 to £380 currently. ASUS Tough Gaming X670E plus Wi-Fi, that is a mouthful, and the Prime X670E Pro Wi-Fi primarily differ via their appearance. ASUS's Prime board goes for the usual silver and white and black colour scheme, alongside a touch of RGB lighting on the rear I/O cover, while the Tough Gaming alternative is dark greys and blacks. The heatsinks focus on the logical areas very well in my opinion. You get chunky pieces of metal atop the main M.2 SSD slots and the VRM components. And ASUS's Prime board focuses a little more on aesthetics versus cooling of the MOSFET heatsink than the Tough Gaming option, with its somewhat thin cutouts that are clearly more cooling focused. Both motherboards use 8-layer PCBs and operate dual 8-pin CPU power connectors for juice. The 14 plus 2-stage VRM solutions are built around 70 amp rated monolithic power systems, MPS power stages, and 5K rated capacitors. The primary PCIe 5.0 X16 slot is steel reinforced for both motherboards. One key difference, however, is that the Prime gets ASUS's awesome Q release button so that you can easily remove a fat graphics card from a fully built system. And then additional PCIe connectivity comes from two PCIe Gen 4x4 electrical connections, one of which is housed inside a full-size physical slot. 4 M.2 slots are offered by both boards, though the Tough does forego one of the M.2 cooling heatsinks that its Prime cousin also offers. Slots 1 and 3 can run from CPU-fed lanes at PCIe 5x4 and PCIe 4x4 respectively. Slot 4 can do PCIe 4x4 from the X670 chipset, and then slot 2 runs at PCIe 3.0 by 4 or SATA mode on the M.2, but this slot steals bandwidth from SATA ports 1 and 2 when in PCIe by 4 mode, so watch out for some interference there. ASUS's tool-free Q-latch system is used for housing the M.2 SSDs and mounting them in place, and this is an interface that I absolutely love. It just works really well, so convenient. Onboard connectivity is actually one of the few areas where these motherboards differ very slightly, but those differences are very subtle though. The Tough gets 3 ARGB and 1 RGB headers versus the Prime's 2 ARGB and 1 RGB header. Also, the Prime gets onboard power and clear CMOS buttons, which I always love to see. And on both boards, you get many of the main modern connectivity interfaces that you would always want to see. An internal 10GB USB 3.2 Gen 2 Type-C header is present. There's old-style USB 3.0 in the header form, 4 SATA 6GB per second, triple USB 2 headers, which is very good for use with all-in-ones and the likes, and then 8 total 4-pin fan headers. Both motherboards get 10 total USB ports on the rear I/O. These are 1 20GB per second, 4 10GB per second, and 5 5GB per second. The Tough deploys all of its 5GB per second ports as Type A, whereas the Prime swaps one of them for Type-C. Networking is handled by Wi-Fi 6E and a Realtek 2.5GB Ethernet NIC, and then DisplayPort 1.4 and HDMI 2.1 cover the video outputs, while audio is handled by a Realtek S1220A codec. So that's the hands-on overview of these two ASUS X670E motherboards. As you can probably tell at this point, there's not really all that much difference between the two of them, and that's probably representative of their price point too. I would argue, however, that the extra USB Type-C port, onboard clear CMOS and power buttons, ASUS Q release button, and added M.2 heatsink on the Prime are more valuable than the additional ARGB header on the Tough Gaming. So out of these two, the Prime is probably the board I'd go for, even if it was a little bit more expensive. But let us know what you think in the comment section down below. Now we move on to an ROG Strix motherboard that is priced and positioned a little bit higher in the ladder than the previous two options that we looked at from ASUS. This is the horribly named ROG Strix X670E gaming Wi-Fi. The retails for around about £420 in the UK right now, 420 UAE. Someone's going to crack a joke at that, no doubt. Appearance-wise, this motherboard uses the typical ROG Strix design that we're now familiar with. Dark blacks and greys complement a bigger, better chunk of RGB lighting on the rear I/O cover. One key area of upgrade is with the VRM heatsink itself. Now we get a physically larger and better designed serving of metal on top and left-hand sides, and both heatsinks are connected via heat pipe to share thermal load between them. Once again, we see an 8-layer PCB with dual 8-pin CPU power connectors. This time though, the ROG Strix X670E motherboard improves the VRM configuration to a 16 plus 2 stage teamed setup using 90 amp components. That is a very hefty VRM solution indeed. And it's all managed by a DigiPlus VRM PWM controller. For the PCIe slots, the ROG Strix board is actually a little bit less accommodating than some of its lower priced competitors that we just looked at actually. And this is primarily because ASUS has deployed PCIe lane connectivity elsewhere rather than the physical ports in some instances. We still get the steel reinforced PCIe 5.0 X16 slot with ASUS's Q release connector, but now the secondary connections are a PCIe 3x1 slot and a PCIe 4x4 connection in the X16 sized form factor. Realistically though, this is going to be fine for most users of a motherboard at this price point and caliber and with the target audience that this board looks for too. M.2 connectivity gets an upgrade versus the cheaper motherboards. Now, M.2 slots 1 and 2 both support PCIe 5x4 SSDs with their connection coming directly from an AM5 CPU. The remaining pair of M.2 slots support up to PCIe 4x4 bandwidth and run from the X670 chipset. All of these slots are well cooled by metal heatsinks too, and the top slot in particular gets a hugely oversized metal cooling block with front and rear thermal pads. Onboard connectivity is generally similar to the Prime, but there are a few areas where ASUS's new ROG board is actually a little bit better and a little bit worse, funny enough. The ROG Strix board offers up 4 SATA ports, an internal 20 gigabits per second USB 3.2 Gen 2 Type-C header, a reinforced 5 gigabits per second USB 3 header, and dual USB 2 headers. I'd actually like to see triple USB 2 headers like on the cheaper boards because that's just really convenient for connecting RGB boxes or all-in-one coolers, for example. And in terms of onboard RGB headers, 3 are addressable and 1 is the old style 4-pin RGB. It is, however, highly disappointing to see no onboard power or system reset buttons on the motherboard itself. I think at this price point, having those on board for troubleshooting is probably justifiable, particularly as the cheaper board, the Prime, has those. And then in terms of 4-pin fan headers, ASUS provides 8, which is a great number. The densely packed rear I/O sports 12 total USB ports. These are 1 20 gigabits per second, 9 10 gigabits per second, and 2 old-style USB 2. That's an excellent selection, with the 20 gigabits per second USB 3.2 Gen 2x2 running in Type-C form, alongside 2 other 10 gigabits per second Type-C ports. Networking is handled by Intel in the form of a Wi-Fi AX210 or Wi-Fi 6E adapter and an i225V 2.5 gigabit NIC. Once again, we see DisplayPort 1.4 and HDMI 2.1 covering output capabilities for video, while the upgraded Realtek ALC 4080 codec handles the audio side of things. And alongside the rear I/O BIOS flashback button, ASUS deploys a clear CMOS button on the back panel, which is incredibly useful. So that's the initial hands-on overview of the ASUS X670E, of the ASUS ROG Strix X670E gaming Wi-Fi motherboard. Try writing that down. It's going to take an entire page on your printer. This feels like a sensible option for enthusiasts who want a premium motherboard before spending truly eye-watering amounts of money. Not that this board's £400 asking fee is easy to stomach by any stretch of the imagination. I like the strong focus on proper heatsinks. The PCIe and M.2 lane distribution looks to be excellent, and USB connectivity is ample. I would, however, have liked to see some onboard power and reset buttons, just even for troubleshooting purposes. They feel like they're justifiable, but I guess they're not something that people are going to use too often, so yeah, not a big deal. Next up is the ASUS ROG Crosshair X670E Hero. This motherboard retails for over £600 currently. So let's take a look at some of the features that ASUS uses to differentiate this high-end offering. Appearance-wise, everything just looks a little bit more premium, as you'd expect at this price point. The RGB lighting is more noticeable, and the integration between each individual heatsink is simply cleaner from an aesthetic perspective. The VRM heatsinks are absolutely massive and are connected via heat pipe. This design makes sense given that users of a motherboard at this price point may well be pushing hefty overclocks on their processor. ASUS deploys an 18 plus 2 stage power delivery solution using 110 amp rated stages. That is a truly incredible level of maximum theoretical power output and should ensure tolerable operating temperatures. There are also 10K rated black metallic capacitors, and the DigiPlus ASP2205 PWM controller is mounted on the board's rear side. PCIe connectivity is improved to a pair of full-length steel reinforced slots. These run at X16X0 or X8X8 using CPU-fed Gen 5 PCIe lanes. Only the top slot gets the Q release latch though, because that's the one you'll be using with the graphics card. There's also a bottom PCIe 4.0x1 slot too, if you want to add in, I don't know, a Wi-Fi card maybe, even though you've got built-in Wi-Fi. I don't know, you add something in there, I guess. So why so much high bandwidth connectivity given that multi-GPU usage is basically dead on the consumer platform? Yeah, that's a good question. Well, I guess you might have a use case for high bandwidth capture cards, or maybe a RAID setup, or maybe a really high bandwidth networking device, or something like that, or maybe just an additional graphics card for rendering purposes. Yep, there's quite a few things you could put in that secondary PCIe Gen 5 slot. And one of those things is something that ASUS actually includes. So the ROG PCIe expansion card can be used to house and cool a single Gen 5 M.2 SSD. And that's in addition to the 4 onboard M.2 slots. Storage juggernauts, yeah, maybe this board's worth a look, I guess. For those 4 onboard slots, 2 of them are Gen 5x4, and the other 2 are Gen 4x4. Just look at that primary M.2 slot heatsink too. It is absolutely huge. Onboard connectivity is very strong and gets some clear price sensible upgrades versus the cheaper motherboards. The 20 gigabits per second Type-C header can provide 60 watts USB power delivery when the 6-pin PCIe connector is installed. There are now dual 5 gigabits per second USB headers, one of which is reinforced. Triple USB 2 headers is useful, just like the 6 SATA ports. And there's still the same 8 4-pin fan headers. Now, we also get additional onboard power, retry and flex key buttons, alongside a 2-digit debug LED display, which is superb. The Hero's rear I/O is impressive too. There's dual 40 gigabits per second USB 4 via an Intel JHL 8540 controller, and they're the stars of the show clearly. There's also another 20 gigabits per second USB Type-C, and there's ample 10 gigabits per second USB connectivity too. Plus, for video outputs, you get the HDMI 2.1 in addition to the DisplayPort signals carried by the 2 USB-C connectors, or the USB 4 connectors I should say. Networking is Wi-Fi 6E and an Intel 2.5 gig NIC, and then the SupremeFX audio solution is built around the Realtek ALC 4082 codec. Plus, another one that I love to see is proper LED lit clear CMOS and BIOS flashback buttons on the rear I/O where they're easy to access. Clearly, this is a high-end, expensive motherboard that has some high-end, expensive features. To productivity users, dual USB 4 ports are impressive, as is the 60-watt capable front panel USB-C 3.2 Gen 2x2. And for core hardware enthusiasts, that 18 plus 2 stage power delivery solution using 110 amp rated components is going to be very appealing indeed. There's even a graphics card holder if you're worried that your new slab of NVIDIA or AMD FPS horsepower is going to sag under the extreme weight of modern card coolers. Yep, that's a pretty common thing in today's GPU market, it seems. Now we will take a look at the Mini ITX ROG Strix X670E gaming Wi-Fi motherboard. And the price point that this board currently occupies in the UK is around about £460 or so. This is going to be one for all you small form factor enthusiasts out there, I guess. It's easy to see at first glance just how much connectivity ASUS has squeezed into this diminutive motherboard. Firstly though, we can look at the power delivery solution. ASUS has deployed a 10 plus 2 stage setup using 110 amp hardware per stage. While you do get a decent sized heatsink and backplate to cool the MOSFETs, there is a VRM fan that is probably a smart addition for a motherboard intended for small form factor usage. PWM control is handled by the DigiPlus ASP2205 controller. Obviously there's just the single PCIe 5x16 slot, and that's primarily intended for graphics card usage, but further connectivity options come via the stacked M.2 interface. ASUS actually provides installation capacity for 2 M.2 SSDs, one of which will run at PCIe 5x4 from the CPU's lanes. And then there's a small fan that shifts air from the rear I/O area to help cool these 2 stacked storage devices. And then for other connectivity, there's an add-on card that connects via 2 pseudo USB Type-C connectors to offer 2 SATA ports, dual USB 2 headers, and front panel connections. The internal USB 3.2 Gen 2 Type-C header runs at 10 gigabits per second speed, and there's also a 5 gigabits per second USB 3 header for front panel connectivity. 3 4-pin fan headers along the board's top edge seems like a reasonable number for a mini ITX system, as does the pair of RGB headers, one of which is addressable. Once again, dual 40 gigabits per second USB 4 ports from the Intel JHL 8540 controller are star of the rear I/O show. These are absolutely ideal for a mini ITX system whereby high-speed connection to an external graphics card or external storage devices is absolutely critical. Another 8 USB Type-A ports are featured, 5 of which run at 10 gigabits per second, with the others being USB 2. Video output comes in the form of HDMI, as well as DisplayPort via the 2 USB 4 connectors. And then Intel's i225V NIC is used for 2.5 gigabit Ethernet, alongside the Wi-Fi 6E wireless connectivity. Clear CMOS and BIOS flashbacks are 2 glaring, questionable omissions from the rear I/O. But on that note, we should introduce the ROG Strix Hive. As you will note, there's no audio connectivity on the rear I/O either, and that's because ASUS hands over these duties to the ROG Strix Hive unit. This is a small external box that can be connected to the system via USB. It provides BIOS flashback via USB 2 port, as well as an additional 10 gigabits per second Type-C connector. Also, audio connectivity is handled via this box's Realtek ALC 4050 codec and ESS Sabre 9260Q DAC. A 3.5mm headphone or mic jack and a barrel-style optical SPDIF connector provide output capability for the physical connections. In theory, I think the ROG Strix Hive is a good idea. It positions some of the ports in a more easy-to-access region versus the small form factor system back panel, which could be tucked away inside a media cabinet, for example. With that said, the included USB cable for connectivity is way too short for my liking, but that's probably something you can fix yourself with relative ease. And I also question the logic for having a precision boost overdrive button below the volume dial. Not really sure why that's there, because that's not going to be used very often, so yeah, maybe I'd prefer a different button, but I guess you can let me know what you think about that in the comment section down below. ASUS ROG Strix X670E iGaming Wi-Fi has some cool features for mini ITX or small form factor gaming enthusiasts. It also looks to serve up competent hardware via a strong power delivery solution and well-cooled M.2 SSD mounts. And the ROG Strix Hive looks to be a sensible real-world solution to a real-world problem, that is, giving you connectivity where it's easy to access in a small form factor world. So yeah, that's the overview of this one. Let us know what you think on this £460 plus mini ITX motherboard for AM5. Our AM5 test system is built around the high-end Ryzen 9 7950X processor. We've got 32 gigabytes of 6000 megahertz G.SKILL memory, and that's running the Expo profile. Clean power comes from a Seasonic 1.6 kilowatt power supply. The graphics card is a Sapphire Nitro plus Pure RX 6950 XT. And for cooling, we're running a 360mm all-in-one from Deepcool. For this piece, obviously we've got 5 boards here. It's just going to be ridiculous to test all of these really in depth. So we're going to pick one board that we think is going to be very appealing to a wide user base, and that is this ROG Strix X670E gaming Wi-Fi. Many more letters in the alphabet they can put into that one, probably not. But anyway, yeah, we're going to pick this one. Seems to be a nice balance of features. Not crazy money by AM5 standards. Yes, I know it's expensive. And it should give us a good overview of what the lineup is like. So we used the latest BIOS at the time of testing, and that's version 0805 from the ASUS website. And as always, if you want more details on our test hardware, test procedures, the comparison points, then check out the main Kit Guru page. That really supports us too. Let's jump into it. Taking a quick look at the UEFI on the ROG Strix X670E gaming Wi-Fi specifically, this is the same ASUS UEFI design that we've come to really appreciate over time. The layout is clean and very user-friendly, navigation is straightforward, and it is generally very easy to find the settings the one is logically looking for. To be honest, it's hard to put forward any major complaints on ASUS's interface. If you want to mess with manual overclocking, you can. If you want to tweak ASUS's semi-custom overclocking modes such as AI Tweaker Core Flex, you can do that too. I would prefer if the CPU-based fan header could do proper 0 RPM mode via the written interface, but this is a relatively minor point for an otherwise superb UEFI implementation. Out-of-the-box clocks are around 5.1 GHz, which is similar to the other AM5 motherboards that we've tested with our Ryzen 9 7950X sample. As is also typical, the Ryzen 9 7950X didn't quite use its full 230 watt package power allocation as the 95°C temperature limit was hit first. ASUS has a cool feature built into the UEFI that allows users to set a CPU temperature target level whilst also running AMD's Precision Boost Overdrive algorithm. In essence, this should allow voltage and frequency to be optimized, whilst also allowing the CPU to run cooler than the default 95°C limit set by AMD. Called PBO enhancement, we run this mode using the 90°C temperature target setting to see how well it performed. Clock speed was increased by around 25 to 50 MHz on the Ryzen 9 7950X under all-core load-in, yet the temperature levels of the chip dropped to 90 Celsius, which can have some CPU cooler fan curve benefits. High clock speeds but cooler running temperatures are positive. ASUS's PBO enhancement mode seems like a good idea, so we will put it to the test to see how it does in the benchmarks. Computational performance from the ASUS X670E board is good in a variety of tests. ASUS claim that the 90°C temperature target PBO enhancement mode can actually result in increased performance levels looks accurate. We observed slight upticks in CPU heavy scores thanks to a more optimized CPU voltage when running the 90°C temperature target. Focusing on memory, ASUS bandwidth numbers look to be slightly higher than the MSI and Gigabyte AM5 competitors. The latency score, however, is very similar to the other boards. If you care about 3D Mark's tests, the ASUS X670E board delivers what you want to see performance-wise in the CPU profile test, though it is a little behind the pack for the time spy numbers. Once again, the 90°C temperature target PBO enhancement mode improves performance slightly. In terms of actual gaming, the ASUS ROG Strix X670E F gaming Wi-Fi does just as well as we would expect from any other AM5 motherboard. In fact, we saw a slight performance victory in Watch Dogs Legion, though this could well be attributed to game and Windows updates beyond our control. And there's no problems with the speed rating of ASUS M.2 SSD slot. The cooling heatsink kept our drive below 60°C, so that's a positive outcome. Power draw from the ROG Strix X670E F gaming Wi-Fi is a little lower than the Gigabyte and MSI comparisons that we use. That's for test system wall power consumption, I should add, as package power readings tended to be a little higher on ASUS. The 90°C temperature target PBO enhancement mode is impressive. Running the chip with cooler, optimized voltages allowed the package power to be reduced by a little over 10 watts, whilst also resulting in a 25 to 50 MHz greater clock speed. That's a clear positive for ASUS's easy-to-use enhancement mode. VRM cooling on the ASUS X670E F gaming Wi-Fi is solid. Big, chunky heatsinks and a massively oversized VRM make this an unsurprising result. I can confidently say that I'd have zero worries running even the overclocked Ryzen 9 7950X flagship CPU on any of these X670E ATX motherboards, thanks to their hefty electrical VRM setups and solid metal heatsinks. Hopefully this video has been quite an interesting overview of a variety of ASUS X670E motherboards spanning a variety of price ranges. Just to clarify, this is not sponsored content at all. We just got sent a batch of boards to review, and I think this is the best way to cover a bunch of them through overview procedures without taking weeks and weeks and weeks on end to test. So hopefully you've appreciated that and you found some good information here. The ASUS ROG Strix X670E F gaming Wi-Fi that we tested with performed well. The VRM solution looks to be very strong and operating temperatures were pleasing. Performance out of the box was good too. And this is thanks in large to ASUS's UEFI that makes it easy for even novice users to apply expo and set a sensible fan curve. I like ASUS's Precision Boost Overdrive enhanced temperature target mode. I think it's a pretty smart way of doing things. Of course, you can do a temperature target setting on other motherboards' UEFIs, so go through the AMD common BIOS settings or the PBO options. You can do that manually yourself. But it is undeniable that ASUS's approach is very clean and very easy to deal with. Plus, the fact that some actual CPU configuration tweaking beyond temperature targets has taken place is a positive, as this often delivers increased performance even whilst running our test 7950X processor at a relatively low 90 degrees Celsius operating point. There's plenty of competition in the current AM5 market, and all of the motherboards seem to cost a hefty penny across the board if we're being perfectly honest. But I did enjoy working with the roughly £420 ROG Strix X670E F gaming Wi-Fi. This is a well-designed motherboard that delivers stellar performance and a sensible set of features in my opinion. The other option that really caught my eye was the ASUS Prime X670E Pro Wi-Fi, priced somewhere in the range of £360 at some e-tailers currently. This looks to be a sensible entry point onto the X670E chipset from a motherboard with competent core hardware and some nice value-added features. So I really do think that's another one to keep an eye on, and I think it's actually better value than the Tough Plus gaming whatever. Oh, it's too many words. The Tough. It's better value than the Tough Wi-Fi board that it shares many similarities with, in my opinion. Just a few of those value-added features make it worthwhile. So anyway, that's been our review coverage of 5 of ASUS X670E. Oh, too many numbers, too many digits. 5 of ASUS X670E motherboards. Covered 5. I'm done. Let us know what you think in the comment section down below. Which motherboard would you prefer? Is there anyone that takes your particular fancy, or do you prefer some of the other options on the market? Maybe some of the cheaper chipset options like B650, B650E. Let us know what you think. As always, if you like this video, give us a like, subscribe, do all the YouTube stuff. It really supports us. Please do check out the written review on the Kickguru channel. That helps us massively. Patreon, Discord, social media, and the likes. And I will catch you in the next one.